You're looking at a photo of yourself at 18 months old. Someone else is holding the camera. You're wearing something you'd never choose now, standing somewhere you don't recognize, and you feel absolutely nothing. No flicker of memory. No sense of having been there. You know it's you because someone told you so, not because any part of your mind remembers being that person. That should feel strange. Most of us just accept it, but the real answer to why you can't remember being a baby is far stranger than simply being too young to notice. Your brain wasn't failing to record you. It was actively erasing you on purpose, over and over again. Here's the first thing worth knowing. Babies do form memories. This isn't in question. A 3-month-old can recognize its mother's face after a single week apart. A 9-month-old can watch you perform a sequence of actions with a toy and copy it days later. Developmental psychologist Patricia Bauer has spent decades running exactly these kinds of tests on toddlers, and her work is clear. Infants and very young children encode information constantly. The memory system isn't offline. It's wide awake. So if the memories are there, where do they go? For a long time, the leading guess was that early memories simply weren't stored the way adult memories are. No language yet, no sense of self, no timeline to hang events on, so nothing to retrieve later. That explanation felt tidy. It also turned out to be incomplete. In 2014, neuroscientist Paul Frankland and his team at the University of Toronto ran an experiment that changed the conversation entirely. They worked with infant mice, and mice are useful here because their hippocampus, the brain region responsible for filing memories, produces new neurons at an extraordinary rate in early life. Franklin's team taught young mice to associate a specific environment with a mild stimulus, then tested whether the mice remembered it later. The memory faded fast, faster than it should have, if forgetting were only about disuse. Then they did something clever. They artificially slowed down neurogenesis, the birth of new neurons, in a separate group of young mice. Those mice kept their early memories far longer. When the team reversed the experiment and sped up neurogenesis in adult mice, the adults started forgetting things the way infants do. Think about what that means. The very process that was building the mouse's brain was also the process erasing its earliest experiences. Not a lack of storage. Active turnover. Picture your hippocampus as a small filing room. In early childhood, that room isn't just receiving new files. It's under constant construction. New shelving going up daily, old shelving being torn out to make space, wiring rerouted behind the walls almost every week. A file placed in there during the renovation doesn't get lost because someone forgot about it. It gets lost because the room it was filed in doesn't exist anymore in the same configuration by the time you'd think to go looking for it. That's neurogenesis in early life. Explosive, constant, and structurally disruptive to whatever memory circuits were just laid down. It's also exactly why toddlers learn language, motor skills, and social rules faster than they ever will again as adults. The same rapid rewiring that erases your baby photos from memory is the reason you can now speak, walk, and recognize a stranger's mood from across a room. You traded a set of memories for the hardware capable of building a lifetime of new ones. But there's a second piece to this story, and it comes from a very different kind of research. Developmental psychologist Carol Peterson has spent years running a longitudinal study, sitting down with the same group of children every couple of years and asking them to describe their earliest memories. What she found reshaped how researchers think about the boundary of childhood amnesia. Peterson discovered that the earliest memory a child reports isn't fixed. It shifts. A child interviewed at age 4 might describe a vivid, specific memory from age 2. The same child, interviewed again at age 8, often can't recall that memory at all anymore and instead reports an earliest memory from a later age. The boundary of forgetting keeps moving forward as the child grows, even for memories that were confidently reported years earlier. This is not what you'd expect if memories simply faded like an old photograph, evenly, over time. Instead, it looks like an ongoing edit. Something continues to prune the earliest layer of memory well into middle childhood, long after the toddler years are over. So, which is it? Is your first memory gone because the room it was stored in was torn down by neurogenesis? Or because something kept pruning the archive for years afterward? The honest answer is both, working on different timelines. Franklin's neurogenesis mechanism explains the dramatic wipe that happens in the first few years, when new neurons are flooding the hippocampus fastest. Peterson's shifting boundary research explains why the erasing doesn't stop cleanly at some fixed age. Your brain isn't running one forgetting process. It's running too, stacked on top of each other, both quietly deciding which parts of your earliest self are worth keeping. There's a reason this matters beyond curiosity. Patricia Bauer's research adds a third layer that ties the whole picture together. Even when a very young memory does survive the neurogenesis wipe, it often can't be retrieved the way adult memories are, because retrieval depends on language and narrative structure that a 1-year-old simply doesn't have yet. You can't ask yourself, in words, what happened that day, because at the time it happened, you didn't yet have the internal sentence structure to store it that way. The memory may exist in some fragmented sensory form, it just isn't filed in a format your adult mind knows how to open. So the photo you can't remember being in isn't proof that nothing happened to you. It's proof that something happened to you in a format your current mind was never built to read back. Here's the part that should change how you think about your own childhood. This isn't a flaw in your biology. It's a trade you made without ever being asked, and it was a good trade. A brain that kept every early memory intact would be a brain that couldn't restructure itself fast enough to learn a language, form an identity, or build the flexible, adaptable mind you now rely on every day. The forgetting isn't your brain failing you. It's the cost of your brain successfully becoming something more complex than it started out as. This has a strange mirror in your life right now, one most people never notice. Adult brains still grow new neurons in the hippocampus, just far more slowly than an infant's. That slow trickle of neurogenesis is part of why memories from stressful, transitional periods of adulthood, a big move, a breakup, a new job, sometimes feel oddly hazy in hindsight, even though you were fully conscious and paying attention while they happened. You're not imagining that fog. You're getting a faint echo of the same mechanism that erased your first 2 years, just turned down to a fraction of its original intensity. You also do something else without realizing it. Because you have no direct memory of your earliest years, you build a version of that time out of other people's stories, photographs, and home videos. Ask enough adults about their earliest memory, and a striking number of them are describing something they've been told about, not something they actually experienced. Their brain having quietly stitched a second-hand account into something that now feels like a first-person memory. Your sense of your own infancy isn't a recording, it's a reconstruction, assembled after the fact from evidence, the same way a historian pieces together an era nobody alive today actually witnessed. That's worth sitting with for a second. The self you think you were as a baby is, in a very real sense, a story your current brain wrote about a person it can no longer access directly. None of this means your early years didn't shape you. Attachment patterns, emotional regulation, even elements of temperament are laid down in infancy and carried forward, invisibly, without needing a single conscious memory attached to them. You are the product of experiences you cannot recall having, carried inside a nervous system that was busy tearing itself down and rebuilding itself in order to become you. So, the next time someone hands you a photo of yourself as an infant, and you feel that strange blankness, you're not looking at a gap in your biography. You're looking at the receipt for a transaction your brain made a long time ago, trading a handful of early memories for the capacity to have all the ones that came after. You're looking at a photo of yourself at 18 months old, and you still feel nothing when you look at it. But now you know that blankness isn't absence, it's evidence. It's what a brain looks like after it has successfully finished building the person who would one day be able to ask the question at all.